How can we find the area of this small square with such little information? We know the area of this large square, which is 400, and the length of this side of this triangle. Each four of these triangles are congruent. We have a small square in the middle. Since this is a square, all four of these angles are going to be 90-degree angles. And since this entire angle here will be 180 degrees, each of these angles here is going to be 90 degrees. In other words, we have four congruent right triangles. That's useful because right triangles really come in handy, which you'll see in a moment. Now we're going to use the fact that the area of this large square is 400. Since the area is 400, and also since the area of a square is just the side length times itself, the side length of this large square is going to be 20. Each of these sides has a length of 20. You might be wondering how this is useful. If there's some way we can find the length of this side here, then that would be helpful in finding the length of the side of this small square. And once we have the length of the side of the small square, all we need to do is square that to get its area. So we need to find the length of this leg here in this right triangle. But now that we have these two sides, we can just use the Pythagorean theorem to find the length of the other leg. We're going to have 20 squared is equal to 12 squared plus x squared, where x is just going to represent this length here. By the way, we have 20 by itself on the left side because 20 represents the hypotenuse of this right triangle. If we subtract 12 squared from both sides, we get 20 squared minus 12 squared is equal to x squared. Well, 20 squared is just 400. 12 squared is just 144. This is just 256. So by taking the square root of both sides, we get that x is equal to 16. There are multiple ways that you could have gone about finding the value of x. You also could have just recognized that we have a special right triangle here, a 3, 4, 5 right triangle. All the side lengths are multiples of 3, 4, and 5. But the Pythagorean theorem here works, well, just like in any other right triangle. Now that we know this length here, all we need to do is subtract from this the length of this leg in this right triangle that's on the side. But since we have four congruent triangles, that means this side and this side are both going to have the same length. They're going to have a length of 12. Now that we know the length of this larger side is 16, and the length of this side of the triangle is 12, we can just subtract those two to get the side length of this square, which is just going to be 4, right? 16 minus 12 is 4. And as I mentioned earlier in the video, we just take the square of 4 to get the area of the small square. I'm going to write SSQ to represent small square. So this area is just going to be 4 squared, or 16. And this is our answer. All right. What did you think? Let me know in the comment section if you have any comments, suggestions, or feedback. This is another problem where you can see just how important it is to use the Pythagorean theorem, to know it, and just how often it comes up in various math problems. Anyway, let me know what you think, and I will talk to you all in the next video. Bye now.